8th Standard Mathematics, Chapter 15, Area, Module 2. Let us see area of a trapezium. In the following figure, we have a trapezium A, B, C, D. In this trapezium, AB and DC are the opposite sides which are parallel to each other. So now we have the area of a trapezium formula, that is half into sum of the length of the parallel sides into height. Now we can use this formula to find out the area of any given trapezium. So if you see, it says sum of the lengths of the parallel sides. So in this case, AB and DC are parallel sides to each other, and AP is the height, even BQ is the height. So both of the heights will be of the same length. And by sum of the lengths of the parallel sides, we mean AB plus DC into height, that is AP. Let us do the practice set 15.3. Question 1. In quadrilateral ABCD, length of AB is 13 centimeters, length of DC is 9 centimeters, and length of AD is 8 centimeters. Find the area of quadrilateral ABCD. So if you see the figure, ABCD is a given quadrilateral. Let us start with the solution. So first we'll draw a perpendicular from C to line AB. Name the point E. So in this figure, if you see, we have drawn a perpendicular from C to line AB, and this is point named E. CE and AD would be of 8 centimeters. So if you see, EB will be equal to AB minus AE, which is equal to AB minus CD, as AE and CD are the same. So we'll have 13 minus 9, which is 4 centimeters. Now we'll use the area of the rectangle formula. So area of rectangle AECD will be length into breadth. So that is 9 into 8, which is 72 square centimeters. Area of a triangle BEC, if you see, BEC forms a triangle and it forms a right angle triangle. So we can use half into base into height. So it is half into 8 into 4, and after simplifying this, we get 16 square centimeters. So area of the entire quadrilateral ABCD will be area of the square AECD plus area of the triangle BEC. So area of the square we have found out is 72, plus area of the triangle we got, that is 16. So 72 plus 16 is 88 centimeters square. So area of this quadrilateral ABCD is 88 centimeters square. Practice set 15.3. Second question. Length of two parallel sides of a trapezium are 8.5 centimeters and 11.5 centimeters respectively, and its height is 4.2 centimeters. Find its area. So if you see the given figure, the two parallel sides of the trapezium, this is 8.5 and this is 11.5, and the height is 4.2 centimeters. So we'll use the area of trapezium formula, that is half into sum of parallel sides into height. Substituting the values, we get half into sum of parallel sides, that is 8.5 plus 11.5 into height. Height, that is 4.2. So 8.5 plus 11.5 will give you 20. So this becomes half into 20 into 4.2, which is 42 square centimeters. Practice set 15.3. Question number 3. Quadrilateral PQRS is an isosceles trapezium. Length of PQ is 7 centimeters. Segment of PM is perpendicular to segment SR. Length of SM is equal to 3 centimeters. Distance between the two parallel sides is 4 centimeters. Find the area of quadrilateral PQRS. So if you see, PQRS is a isosceles trapezium, and by isosceles trapezium means the non-parallel sides will be equal. So in the given figure, PS and QR are the non-parallel sides, hence PS and QR will be equal to each other. So first what we'll do is we draw a perpendicular from Q to line MR. Where it meets line MR, name it point N. So MN and PQ will be equal to 7 centimeters. Now if you see in triangle PMS, we'll use Pythagoras theorem since PM is perpendicular to SR. So by Pythagoras theorem, we have PM square plus SM square is equal to PS square. Substituting the values of PM and SM, so we get for 4 square plus 3 square is equal to PS square. So as we know, 4 square is 16 and 3 square is 9, and 16 plus 9 will give you 25. And taking the square root, we get PS is equal to 5 centimeters. Now, since PQRS is an isosceles trapezium, as I said earlier, an isosceles trapezium, the non-parallel sides are equal to each other. So PS and QR are the non-parallel sides. So PS and QR will be equal to 5 centimeters. So PM and QN, PM and QN. Okay, so QN will also be 4 centimeters because PM is 4. So QN is also 4. And NR and SM will be 3 centimeters. So SR will be SM plus MN plus NR, which is equal to 3 plus 7 plus 3, which is equal to 13 centimeters. So length of SR is 13. Now we have obtained the length of both the parallel sides. So if you see this figure, this is QN, PM and QN both are 4. Now we have got the length of both of the parallel sides. So we'll use the area of trapezium formula, that is half into sum of parallel sides into height. So that will be half into sum of parallel sides, that is 7 plus 13 into height, that is 4. So simplifying this, you will get 40 centimeters square. Hence, the area of the trapezium PQRS is 40 centimeters square. Next, we'll see area of a triangle. Now, we already know one formula for area of a triangle that says area of a triangle is equal to half into base into height. Now, this is a new formula. In case in the triangle, all the three sides of a triangle, the lengths of all the three sides of a triangle are given, then we can use a simple formula to find area of a triangle. So you see ABC is a triangle and the sides of this triangle are denoted by small letters A, B, C. So first we'll find the semi-perimeter of the triangle. The semi-perimeter formula is half into A plus B plus C. So A, B and C are the lengths of the sides of the given triangle. Then we can use the area of a triangle formula. This formula is also called as Heron's formula. So area of a triangle is equal to under root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C. As we know, S denotes the semi-perimeter. This formula we can find, with the help of this formula, we can find the area of the given triangle if the height and the base is not known, but the length of all of the three sides are known. Let us now see some examples and find out the area of a triangle. So as I said, this formula is also known as Heron's formula. Practice set 15.4. The first sum. Sides of a triangle are 45 centimeters, 39 centimeters, and 42 centimeters. Find its area. Let us start with the solution. So let us take A to be 45 centimeters, B to be 39 centimeters, and C to be 42 centimeters. So we'll first find out the semi-perimeter. Semi-perimeter formula is S is equal to half into A plus B plus C. Substituting the values of A, B, and C, we get half into 45 plus 39 plus 42, which after dividing it by 2, you'll get 63. Now we'll use the area formula, that is under root of S into S minus A, S minus B, S minus C. And the value of S is 63. Substituting the values, we get 63 into 63 minus 45 into 63 minus 39 into 63 minus 42. Solving this and simplifying, we get the area is equal to 756 square centimeters. Let us do the second question. Look at the measures shown in the adjacent figure and find out the area of quadrilateral PQRS. Now first what we do is we join PR. Now in triangle PSR, we can apply Pythagoras' theorem. By Pythagoras theorem, we get PS square plus SR square is equal to PR square. Substituting the value, PS is 36, so 36 square plus SR is 15, so 15 square. So PR square will be equal to 1296, that is square of 36, and square of 15 is 225. So 1296 plus 225 will give you 1521. Taking the square root, we get 39 meters. So PR is equal to 39 meters. Now, if you look in triangle PSR, S is equal to half. We'll find out a semi-perimeter. So that is half into 56 plus 25 plus 39, which will give you 60. So this value of S is 60. And now we'll use Heron's formula to find the area of triangle PSR. Substituting the value of S, A, B, and C, we get 60 under root of 60 into 60 minus 56 into 60 minus 25 into 60 minus 39. Now solving this and simplifying it, we get the area of triangle PQR of triangle PSR to be 420 square centimeters. So now we can find triangle area of triangle PSR. So if you look at the figure, this is the area of triangle PSR. So area of triangle PSR will be half into base into height. So the base is 15 and the height is 36. So half into 15 into 36 will give you 270 square meters. So area, if you look at the figure, area of this triangle is 270 square meters and area of this triangle is 420 square meter. Now to find area of the entire quadrilateral, we just add area of triangle PSR plus area of triangle PQR, because these two triangles combine and they form area of the quadrilateral PQRS. So that will be 270 plus 420, which is 690 meters square. So area of this entire quadrilateral PQRS is 690 meters square. Let us do the third sum. Some measures are given in the adjacent figure. Find area of triangle ABCD. So let us start with the solution. We have to find area of the quadrilateral ABCD. So area of this entire quadrilateral has to be found out. So first we find area of triangle BDC. So you see area of triangle BDC, we can find out this entire triangle by using half into base into height formula. So half into base, that is 60, and height is 13. So this becomes half into 13 into 60, which is 390 square meters. Now if you look triangle BAD, now here also again this is a right angle triangle, so we can use half into base into height formula. So half into base is AD, height is AB. So half into 40 into 9. Simplifying this, we get 180 square meters. Now to find area of this entire quadrilateral ABCD, we just add area of triangle BDC plus area of triangle ABD. So, so that was 390 plus 180, which is 570 meters square. So area of this quadrilateral ABCD is 570 meters square. Let us see area of figures having irregular shapes. So first, let us understand what is an irregular shape. So any shape which does not follow geometric rules are irregular shapes. So to find area of irregular shapes, what we can do is we can break down the irregular shape into regular shapes like triangle, parallelogram, quadrilateral, square, rectangle, and so on, and find the area of each of the regular shapes, add them up to get the area of the irregular shape. Let us see one such example of practice set 15.5. The first question. So this is a shape, irregular shape given, and we need to find the area of this shape. Now, if you see, this shape can be divided into subfigures. So if you see, this first subfigure would be a triangle, then we have a trapezium, then again a triangle, and so on. So we'll find area of each of the subshapes or the subfigures, add them up to find area of this entire irregular shape. So let us start with the solution. So first we'll start with finding area of triangle PQA. So now this is a right angle triangle, so we can use half into base into height formula as the base and height lengths are given. So that is half into 30 into 50, which is 750 meters square. Next, if you see area of triangle PBT, PBT, that is this below one triangle, and we can find the base, since it is a right angle triangle, again we can find a base and height. So the base, if you see here, will be 30 plus 30, that is 60, and the height is 30. So using the formula half into base into height, that is half into 60 into 90. Simplifying this, we get 900 meters square. Now if you look at triangle SBT, so look at the triangle SBT, that is this triangle. Again, this is a right angle triangle, so we can use half into base into height formula. So if you see, the base would be 60 plus 30, that is 90, and the height is 30. So half into 90 into 30 will give you 1350 meters square. Now, if you look at area of triangle RCS, that is this triangle here, the base is 60 and the height is 25. Again, using the same formula, half into base into height, we get half into 25 into 60, which will give you 750 meters square. So area of this triangle is 750 meters square. Now we are left with this quadrilateral portion here, that is QACR or QRCA. So now this forms a trapezium. So here we'll use a formula for trapezium, that is half into sum of parallel sides into height. So that would be half into parallel sides are QA and RC. So QA plus RC into height. So height is AC. So this would change to half into 50 plus 25 into height, that is 30 plus 30, which is 60. So this gives you half into 50 plus 25 into 60, that is 2250 meters square. So area of this portion is 2250 meters square. Now we have found out area of each of the sub portions here. Now to find the area of this entire irregular figure PQST, we just add up area of each subfigures that we found out. So it will be area of PQA plus area of PBT plus area of SBT plus area of RCS plus area of QRCA. Adding up all this, 750 plus 900 plus 1350 plus 750 plus 2250 will give you 6000 meters square. That means area of this entire irregular shape is 6000 meters square. Next, let us see area of circle. To find the area of circle, we have to keep in mind the two main formulas, and the first one is area of circle formula, that is pi r square, and then the circumference of a circle, that is 2 pi r. So if you see, circumference means just the length of the outer layer or outer line of the circle. So let us start with the sum. Practice set 15.6, the first one. Radii of the circles are given below. We have to find their areas. So we'll use the area formula, that is area is equal to pi r square. So first one, when the radius is 28 centimeters, we substituted in this, taking the value of pi to be 22 upon 7. We get area to be 2464 square centimeters. Second one, taking the radius as 10.5, substituting in this formula, pi value should be 22 upon 7. We get the area to be 346.5 square centimeters. Third one, in when the radius is 17.5 centimeters, substitute the value in this formula, a is equal to pi r square, we get area to be 962.5 square centimeters. Practice set 15.6, question 2. Now in this question, if you see, area of some circles are given. Using that area formula and the area of the circles, we have to find the diameter of the circle. So let us start with the solution. So first circle, its area is 176 square centimeters. So we have to find out the diameter. So the diameter, once we substitute this in the area formula, once we substitute this in the area formula, so as we know, the formula for area is equal to pi r square. So we take the value of pi to be 22 upon 7. So area is 176. Pi will take it to be 22 upon 7 and r square will keep it as it is. Rearranging this in terms of r square, so we'll get this 176 into 20 into 7 divided by 22. So as we know, 176 into 7 will give you 1, 2, 3, 2, and this divided by 22. So when we divide 1, 2, 3, 6, or 1, 2, 3, 2 divided by 22, we'll get 56. So we get r square is equal to 56. Now if we take square root both the sides, we have to find a square root of 56. So we can keep this value as it is. So the radius is 50, square root 56. Now since the radius is square root of 56 and we know diameter will be 2 times the radius. So diameter will be equal to 2 into square root of 56. Hence we can say that the diameter value is 256. Next, practice set 15.6, the third question. So here, diameter of a circular garden is 42 meters. There is a 3.5 meter wide road around the garden. We have to find the area of the road. So if you see this portion, this circular portion, inner portion, it is a road and we have to find the area of this circular road. So if you see, this is a concentric circle and we have to find this portion. So that can be done by finding area of the bigger circle, then finding area of the smaller circle and subtracting it. So once you subtract area of the bigger circle minus area of the smaller circle, we'll get area of this portion here. So let us start with the solution. Diameter of the garden. So that is diameter of the bigger circle is given 42 meters and the radius of the bigger circle will be 21. That is half of 42. Diameter of the garden including the road, okay, that is 442 plus 3.5 meters plus 3.5 meters. So including the road, the diameter of the garden will be 49 meters. So that means 42 is the radius of the inner circle and 49 is a radius of the outer circle. That is, bigger circle is having radius 49, having diameter 49 and inner circle is having diameter 42. So radius of the inner circle is 21 meters and radius of the outer circle is 24.5 meters. So now we know radius of both the inner circle and we know the radius of the outer circle. Now we can find the area of the road by finding area of the garden with the road, that means area of the outer circle, minus area of the garden, that means area of the inner circle. So if we say the radius of the bigger circle as capital R and radius of the smaller circle as small r. So area of the garden, that is area of the bigger circle, is pi r square minus area of the smaller circle, that is small pi r square. So taking pi common, we get pi into r capital R square minus small r square. Substituting the value of pi is 22 upon 7 into capital R, that is area of the bigger circle, radius of the bigger circle, that is 24.5 20 meter square, and area of the smaller circle, that is 21 meters square. So substituting this and finding out the square and subtracting it and multiplying it with 22 upon 7, we get 500.5 square meter. That means area of this portion or area of the road is 500.5 square meters. Practice at 15.6, the fourth one. We'll find the area of the circle if its circumference is 88 centimeters. So we'll use the circumference formula. So circumference is 88 centimeters. Circumference formula is 2 pi r. So 2 pi r is equal to 88. Dividing both the sides by, or what we can do is we can substitute the value of pi. So pi is 22 upon 7 into r is equal to 88. Rearranging this in terms of r, we get 88 into 7 divided by 2 into 22. So we can rearrange, simplify this. So this becomes 11 twos are 11 fours are. So this becomes 4 into 7 divided by 2, that is 28 divided by 2, which will give you 14. So r is equal to 14 centimeters. So we can say that now we need to find the area. So substituting the value of r in this, so that is 22 upon 7 into 14 square. Since r is 14, so this will become 616 square centimeters. So area of the circle whose circumference is 88 centimeter is 616 square centimeters. That's it for this video. Thank you.